Trigonometric functions of angles in various quadrants and coterminal angles. Now let us discuss the sign of trigonometric functions of angles in different quadrants. That means if the terminal side of an angle lies in various quadrants, what will be the signs of the trigonometric functions? First, let's consider first quadrant. In the first quadrant, the terminal side lies in the first quadrant for this angle theta. Initial side is always on the positive direction of x-axis. Now, to apply this definition of trigonometric functions, we need to take any point on the terminal side. Any point on the terminal side of this angle will be in the first quadrant. Being in first quadrant, both coordinates will be positive. And the direct distance of P from the origin R will always be positive. So, x coordinate, y coordinate and R, all the three numbers involved in the trigonometric functions are positive. So, whichever ratio you calculate, they will all turn out to be positive, 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 positive. So, trigonometric functional values of an angle whose terminal side lie in the first quadrant will all be positive. In other words, trigonometric functional values of an acute angle means between 0 and 90 degree, between 0 radian and pi by 2 radian. Any angle, its terminal side will lie in the first quadrant, and all trigonometric functional values will be positive since the three numbers x coordinate, y coordinate and r, all three of them are positive. Now let us check in case we want to consider an angle in the second quadrant. That is, we will have a new angle whose initial ray is the same, positive direction of x-axis. An angle having terminal side in the second quadrant. Its value, the angle, will be between 90 degree and 180 degree or between pi by 2 radian and pi radian. This kind of an angle is called an obtuse angle. What about this angle's trigonometric functional values? For that, let us take a point on the terminal side. Any point on the terminal side will have the signs negative, positive, because to reach this point on the x coordinate you need to go to the left side negative but upside positive, positive y coordinate. So negative, positive will be the coordinates x and y. Now but the direct distance from the origin to P is always taken as positive. So the sine theta y by r, y coordinate positive upon r positive will be positive. But cos theta x by r, x is negative and r is positive. So negative upon positive is negative. Tan theta y upon x, y coordinate upon x coordinate, positive upon negative, that will be negative. Cot theta negative. Sec theta will be negative and cosec theta positive. As we know, sin theta and cosec theta are reciprocals. So if sin theta is positive, obviously cosec theta will also be positive. So we understand that trigonometric functional values of any angle whose value is between 90 degree and 180 degree will be like this. Only sine value and cosec value will be positive, rest all will be negative. That is what happens when the angle has the terminal side lying in the second quadrant. Let's go with the another angle which has the terminal side in the third quadrant. Here it goes. Now the angle is more than 180 degree. Going further, Or in other words, angle is more than pi radians, but below 3 pi by 2 radians. So the terminal side is lying in the third quadrant. In the third quadrant, any point on the terminal side will have the coordinates in the form negative, negative, because x axis negative, y axis negative, x and y both negative. But r is the direct distance from the origin to P. That cannot be negative. That is always taken as positive. So using these three numbers, now let us see what will happen to these trigonometric functional values. Sin theta y upon r. Y is negative, r is positive. Negative upon positive is negative. Cos theta, again x upon r, negative. But look, tan theta is positive. Why? Because it is y upon x. Y upon x, negative upon negative, positive. If tan theta is positive, cot theta will also be positive. Sec theta and cosec theta negative. This is the case of third quadrant. This is the case of the angles which has the terminal side lying in the third quadrant. The value of the angle is between 180 degree and 270 degree. Any of those angles will have trigonometric values, positive, negative in this order. Now the last quadrant, fourth quadrant. Now, taking a terminal side in the fourth quadrant, point will have the coordinates in the form positive, negative. To the right side of x-axis positive, down negative. That is positive, negative will be the coordinates signs. And r is always positive. So sin theta will be y upon r. Negative upon positive is negative. Cos theta is x upon r. X is positive, y is positive, r is positive. So positive here. If sec theta is positive, sec theta, if cos theta is positive, sec theta will also be positive. Rest all going to be negative. Here it goes. Now, this distribution of the signs for various angles in the quadrants are to be remembered very seriously. To remember them, you may remember it like this. Take the four quadrants. In the first quadrant, all are positive, obvious. All are positive. But in the second quadrant, only sign value is positive. Of course, the reciprocal will be positive. The reciprocals we will calculate if you remember these three of them. You need to remember only the three. Rest are the reciprocals. You need to know the appropriate reciprocals. Now in the second quadrant, sign is positive, you remember. Obviously, cosec will also be positive. So right here, sign positive. Now in the third quadrant, tan theta is positive. Tan theta positive in the third quadrant. Obviously, once tan theta is positive, cot theta will also be positive. And lastly, in the fourth quadrant, cos theta and its reciprocal sec theta will be positive. So, in the first quadrant, all, second quadrant, sin theta, third, tan theta, fourth, cos theta. All, sin, tan, cos. Remember it. Trigonometric functions of coterminal angles. Let me draw an angle in standard position, angle theta, having the terminal side in the first quadrant. It's an acute angle. Now, a point P, x, y is taken on the terminal side. The distance of P from the origin, called r, which can be calculated using the distance formula, x minus 0 whole square plus y minus 0 whole square under the root is root of x square plus y square, that is equal to r. Using these three numbers, trigonometric functions of this angle theta is defined. y by r, x by r, y by x, x by y, r by x and r by y respectively. All possible ratios. This is a definition of trigonometric function. Now, let me draw a new angle. The angle is little more than 360 degree. That is, while drawing it, full rotation 360 plus theta more. So, this angle is more than 360 degrees. Now you notice the second angle 360 plus theta also has the same terminal side. So this angle theta and angle 360 plus theta are called coterminal angles having same terminal side. Now if you want to take a point on the terminal side, it will be the same point. Hence, the direct distance will also be the same. Trigonometric ratios of this new angle will be the same. Since all points on the terminal side theta lies on the terminal side of 360 plus theta, the ratios of x, y, r are equal. Hence, trigonometric functions of coterminal angles will be equal. So, 360 plus theta, this angle's trigonometric ratios will be same as angle theta's trigonometric ratios. So, sine 360 plus theta is same as sine theta. Cos 360 plus theta is same as cos theta. Tan 360 plus theta is same as tan theta, etc. So, after one full rotation, whatever the angle is taken extra, that angle's trigonometric ratios will be, trigonometric functional values will be the same for the coterminal angle 360 plus theta. Now, in general, if the angle has one more rotation, say for example, 360 plus 360 more, that is 720 plus theta, then also the trigonometric functional values will remain the same. The reason is this: any point that we want to take on the new terminal side will be same point on the original terminal side. So, trigonometric functions of coterminal angles are equal. Using the fact that trigonometric functions of coterminal angles are equal, let's have some examples. Angle theta, I'm taking 30 degree. Sin theta, sin 30 degree is half. It is already known to us. Now, if we want to find out sin 390 degree, what is 390 degree? 390 degree in standard position is drawn like this. That is, after one full rotation, 30 more, 360 plus 30. So rewrite this 390 as 360 degree plus 30 degree. This 360 degree gives one full rotation. After that 30 more. Now because of that, we find 390 degree and 30 degree are coterminal angles. So sine of 390 degree should be equal to sine of 30 degree, which is already half. So sine 360 plus 30 degree is equal to sine 30 degree, which is equal to half. Another example. Sine 750 degree. Let's see, how do we draw 720 degree, 750 degree? One rotation 360, one more rotation makes it 720 plus 30. So this 750 can be written as 720 plus 30. Again, 720 stands for two rotations. 360 plus one more 360 makes it 720 plus 30. So this 30 degree and 750 degree are also coterminal angles. So we have to say it is sine of 30 degree itself. Look, 720 degree is being written as twice of 360 degree. Twice of 360 degree means two rotations. And sine 30 value is half. One more example. Sine of 1110 degree. Here, let's calculate and see how many rotations are there in this given angle 1110 degree. We'll go for simple division. 360. We're going to divide the given number by 360. Yes, 3 times. Let's multiply. 3 into 0, 0. 3 into 360 is coming 1080. Subtract. The balance is 30 degree again. So, this 1110 can be written as 3 plus 30 upon 360. Or we can say 3 into 360. 3 times 360 plus 30 will be 1110. So, this angle is now rewritten. 3 times 360 plus 30. 3 times 360 is 1080. Plus 30 will make it 1110. So, here it says sine of an angle which is 3 rotation plus 30. Again coterminal with 30 degree. Therefore, it must be equal to sine 30 degree, that's equal to half. This is how we manage to get the trigonometric functional values of angles more than 360 degree. Angles more than one rotation. Any number of rotations we can go ahead like this. Another example. Tan of 1845 degree. To know what is 1845 degree, let's go for the division. 1845 divide by 360 to see how many rotations are there in it. Simple division. Let me take 5. Multiplied, it is coming 1800. Balance, subtract and see it is 45. So we can say that 1845 is 5 times 360 plus 45. 5 times 360 plus 45. So this 1845 degree is coterminal with 45 degree. 5 times rotation plus 45 degree. So it must be equal to tan 45 itself. Tan 45 is 1. Next, tan of minus 420 degree. First of all, this angle is a negative angle. So we need to recollect this set of identities. Tan of minus theta is equal to minus tan theta, we already derived. So write the next step as minus tan 420 degree using this identity. Minus tan 420 degree. Now we will go for 420 degree. How to write in terms of rotations? 420, there is 360 only once in it. Subtract. We have the balance 60. So it is, remake this minus, you retain and write 420 as 360 plus 60. So 420 is coterminal with 60 degree. So tan of 360 plus 60 is tan 60 degree itself. And this minus is retained there. Tan 60 degree value is root 3. So here we get this answer minus root 3.